So welcome back to lesson 2, the first vector. But before we get started for the lesson 2, here's a reminder for you before you watch lesson 1, please make sure you finish homework 0. Okay, homework 0 is a review of my class policy and also the key information from syllabus. So if you haven't done homework 0, please pause this video and do the homework 0 first. And after that, come back for the lesson 2, the force vectors. So, well, for this lesson, after this lesson, you should be able to, like, giving you any the force acting on any object, you should be able to resolve those force into two axes. So, for example, here, example 1, we give you there is a force acting on the pipe. So you are supposed to find, or you are supposed to resolve the force into the components along with the u and the v axis. And also you should be able to determine what will be the magnitude of each of those components. So how should we touch upon these questions, like what we should do? So first, we can construct a line which is parallel to the u and the v axis. Okay, and we can form the parallelogram first. And also the next step is to resolve the force into the u and the v component respectively. And the last step is to find the magnitude of the components from the law of the sign. Okay, so let me show you this example. So as we mentioned in the last slide, the first step is draw the lines parallel to u and v axis. So as we see here, let's draw a line. The two right line is parallel to u and v respectively. Okay, so after we draw this line, we form a parallelogram. Okay, here is a parallelogram. So after this, what should we do? So we can redraw the top portion of the parallel, which is this portion. Let me mark it in the blue color. We can redraw the top portion, which is in the blue color, of the parallel to illustrate a triangular, okay, which is a head to head, which is a head to tail, which is addition of the components. You can see here is the FV component, here is the FU component. And also we know the angle of this triangular. So this angle is a 45, this angle is a 30, and therefore the other angle will be 105. Okay. So how to solve the magnitude? As we mentioned before, we need to use the law of the sign. So what's the law of the sign? Just to refresh your memory. So for any given triangular, like we show on the right side here, so for any given triangular, it has three lines, A, B, C, and it has three angles, angle A, B, and C, which is shown in a small letter. So sine law, which means the A over sine A, the angle A equals to B over sine B equals to C over sine C. And by this sine law, we can solve the magnitude of the FV and FU. Okay. So because we already know the F equals to 30 lab, okay, and we also know all of the three angles. So let's write down the equation. So based on sine law, we can write here the 30 which is the f's magnitude. So we write a 30 down here. 30 over sine A. The sine A is 105 for this question. So this one should be equal to Fu over 45 degree and should be also equal to Fv over 30. So if we look at this part, we can write down Fu equals to 30 over sine 105 and times sine 45. So use a calculator, you can get the answer will be 22.0 laps. Okay, and similarly, if we look at the first item and the last item, okay, we can get Fv equals to 30 over sine 105 times sine 30, which will be equal to 15.5 laps. Okay, here is how we solve the magnitude of the Fu and Fv. Okay, let's take a look at another example. So what if we have three concurrent forces acting on a tent post? So we're given F1, F2, and F3. So we have axis X and Y, and we want to find what's the magnitude and angle of the resultant force. So our plan, first, let's resolve the force, each of the force, okay, into their X and Y components. And then we can add the respective components to get a resultant vector. And last, we can find the magnitude and angle from the resultant components. Okay, here the same figure. So F1 is perpendicular to the y-axis, so which means the F1's components on the x direction is 0. So we can write down F1 equals to 0 times I vector plus 300 times G vector. Okay. So we know that G vector is the direction of the y-axis, I vector is the direction of the x-axis. So here is how we write down the F1. So F2, we know the angle between the F2 force and x-axis is 45 degree. So what's the F2's component on the x direction? So its magnitude should be F2 times by cosine 45 degree. And because F2's components on the x direction should be opposite to the x direction, so we need to put as a minor. Okay, so it will be minor F2 times by cosine 45 degree times by I vector, and its components on the y direction will be F2 times by sine 45 degree times by G vector. And should this be positive or negative? So it should be positive because the F2's direction is to the upward. So which means its component on the y direction is positive. So how about F3? So we know the F3. We were given the slope of F3. So the slope is the number we can use directly. So which means F3's its component on x direction will be f3 times by 3 over 5, and this should be positive, plus f3 times by 4 over 5 times by g. This should be also be positive. Okay, so please pause this video for a while and replace like the f2, f3's number with its magnitude, like replace f2 equals to 450 Newton, f3 equals to 600 Newton, and use a calculator to solve what's a cosine 45, sine 45, and also what's a f3 times by 3 over 5, what's a f3 times by 4 over 5. Okay, let's please pause this video for a little while, and we will check your answer later. Okay. So well, here's the answer for the f1. Here's the answer for the f2. Here's the answer for the f3. Okay, so far we get the f1, f2, and f3's its component on x and y axis respectively. So what's the next step? As I mentioned before, we need to add the respective components to get the resultant vector. Okay, so which means let's calculate the f resultant, the fr. It will be the addition of the vectors on the I direction or on the x-axis and the addition of the vector on the g direction on the y or the y-axis respectively. So the fr is addition on the x direction will be 0 minus 318.2, okay, which is the components of the f2, plus 360, which is the components, which is the x component from the f3. So if we use a calculator, 0 minus 318.2 plus 360, we can get the resultant first. On the x direction will be 14.1.8. And also what's the answer for the y direction? It will be the f1's direction on the y, f1's component on the y direction, which is 300, plus f2's component on the y direction, which is a positive 318.2, and also f3's component on the y direction, which is 480. So finally we got fr equals to 14.0.880 I plus 1098 times by g. Okay. So here's the fr. And what's the magnitude? So fr equals to the 14.1.8 square plus 1098 square in the square root. So use a calculator, we can find that the answer will be the magnitude of the resultant will be 1099. And what's the angle between the fr and the x? Will be the reverse of the tangent of the fy over fx, which will be 1098 over 14.80. So the answer will be 187.8. Okay, here are some reading quizzes. So first question is, which one of the following is a scalar quantities? So number 1 is the first, number 2 is a position, C is a mass, D is a velocity. So which one is a scalar, or in other words, which 3 is not a scalar quantity? Or which 3 is a vector quantity? So force, definitely it has a magnitude and a direction. it should be a vector. Position, it also be a vector. And for the mass, it should be the scalar. And for the velocity, it also has direction, angles, and also it should be a vector. Okay. So for the vector addition, you have to use which law? Okay, the answer should be D, the parallelogram law. Okay, we use the parallelogram law in the example 1 to find what's the resultant of the F1, F2. So another quiz, please resolve the F along the X and the Y and write it in a vector form. So the F may know its magnitude is 18 Newton. So the angle between F and Y axis is 30 degree. So if we want to get this component to the X direction, X axis, it should be F times by sine 30, and it should be positive. And on the Y axis, it should be F times by cosine 30, and it should be a negative. So answer should be C. And next one, determine the magnitude of resultant F1 plus F2 force. In Newton, when F1 equals to 10I times 20G Newton and F2 equals to 20 plus 20G Newton. So we know F equals to F1 plus F2, which become 30I plus 40G, and the F will be equals to 30 square plus 40 square under the square root. So the answer should be 15 Newton. Okay. That's pretty much for this lesson.